Thank you for joining me on exercise 6E. I'm going to be looking specifically at question 3 part C. It says given theta lies between 0 degrees and 360 degrees. That's one way to write it in words or in symbols. And what this is saying is that we're dealing with all four quadrants, not just restricting our answers to a particular quadrant. And when we deal with all four quadrants, what we're saying is there's the cast rule, where we know that they're all positive in quadrant 1. Only the sign is positive in quadrant 2. Only tan is positive in quadrant 3. And only cos is positive in quadrant 4. So that's an important concept. Oh, I didn't finish writing the question. And we're told that tan of theta is negative 2.36. All right, we're going to need a calculator, so let's get a calculator ready. Okay. Well, there are two tools I use in this question. I've already prepared the first tool, which is the cast rule. And the other one is the concept of the rules, which are theta for acute angles, the acute angles. In the second quadrant, 180 minus theta. In the third quadrant, 180 degrees plus theta. And in the fourth quadrant, 360 degrees minus theta. We need that tool, and let's start. So we can see that tan is negative, and we've got to ask ourselves which quadrants is tan a negative? Where is tan negative? Tan is only negative when it's not positive. So we're dealing with when sine is positive, tan has to be negative in quadrant 2. So definitely a quadrant 2 angle. And where is tan negative again? Tan is negative again when cos is positive. So definitely a quadrant 4 angle. Quadrant 4 angle. What did I do? Where is it gone? I can't find it. Where are you? Here you go. Okay, sorry about that. And quadrant, and I was trying to change the color to blue. Quadrant 4. Okay, there's my two quadrants. So let me highlight. We're dealing with quadrant 2 and quadrant 4. Good. So because tan is negative in quadrant 2, tan is negative in quadrant 4. Now that I know that is, what acute angle will tan of theta equal 2.36? Notice I ignore the negative here because I'm looking for that acute angle. So I will use the calculator here. It's possible to get a tan value bigger than 1. Cos in the last question, you would have had the problem of cos being smaller than negative 1. Doesn't work. Sine and cos are always between negative 1 and positive 1. But tan is fine. So let's go to degrees. We got a degrees in the calculator. So check. We got degrees in the calculator. Let's now cancel that old question. And we're going to take the second function off and only have the tan button. Oh no, we need to find the inverse tan of 2.36 because tan of the angle is 2.36. So the inverse tan, or in some schools they say arctan, that's the same as inverse tan. Just thought I'd share that with you. So put 2.36, hit second function. We want tan to the -1, inverse tan. It's degrees. Good. Hit that button, and we've got our acute angle is about 67.0 degrees. We'll round it off to 1 decimal place. Good. Now we've already established our angles are in quadrant 2 and quadrant 4. So our theta the theta this is I'm going to change theta because I'm going to give an acute angle alpha because our answer, we need to find theta. Just it's okay, no problem. Just know that this theta is not the answer theta because our answer theta cannot be our first quadrant angle. All right, we say our solutions or our answer is in quadrant 2 and quadrant 4. And quadrant 2 is 180 minus 67.0 degrees, and quadrant 4 is 360 minus 67.0 degrees, and then you've got your two answers. So we've got 100 and what's that? 13.0 degrees, is that right? And we've got 293.0 degrees. Let's check. 180 minus 67.0 degrees is 113, yes. And 360 minus 67 is 293 degrees. Good. And there is our two solutions. So just in summary, because I still got your attention maybe, we dealt with a tan as negative, so we knew it was quadrant 2 and quadrant 4. So later, at the end, we used our quadrant 2 and quadrant 4 rules with our acute angle that we got out of our calculator by using just the positive value in the calculator. That will give us an acute angle, but we use the acute angle in the two rules to get our final solution. I hope this has helped. Until next time, stay happy.